Okay, welcome to the video walkthrough for assignment 5, in which we are using the Google Public Data Explorer or Gapminder to create a scatterplot and then writing a short paragraph interpreting that scatterplot. You can use either Gapminder or Google Public Data Explorer to complete this assignment. Gapminder tends to be a little bit easier. So if you go to the Gapminder website, it's actually Gapminder World that you'll be using. So when this starts, you're going to see a scatterplot that shows up and a couple of different places in which you can change the variables. So in this case, what we're looking at is what's actually called a bubble graph. This is showing income per person against life expectancy. So what we're looking at here is a positive relationship. As income gets greater, as GDP per capita gets greater, life expectancy increases. All of these places are colored by region, so we've got a map up here that highlights each region: Sub-Saharan Africa, Europe and Central Asia, and so on. And what this lets us do is sort of look at both the regional patterns, so we can see Sub-Saharan Africa coming down here at the tail with a low income per person and relatively low life expectancy. On the other hand, you can see many countries in the Americas occupying sort of the middle to the top tier, and Europe and Central Asia in about the same spots. So we can break this down by region. We can also break this down by country. So what we're looking for here are outliers, or data values that don't fit with the general pattern. So most of this, as income per person goes up, life expectancy also goes up. But there are a few dots that are sort of outside this main cluster. So Equatorial Guinea, Gabon, South Africa, Swaziland. So we have a few down here that are really not fitting in with our general pattern. So this assignment is going to not only ask you to talk about some of the regional differences, but to talk about outliers as well. So in this case, we'll talk about Equatorial Guinea. If you click on each dot, that'll stay there, and you can position the label around however you like to simplify things. So we'll leave it there. We could do the same thing with the Google Public Data Explorer. We'll come back to Gapminder here in a second. So with the Google Public Data Explorer, the easiest way to get started is by clicking on this first bubble graph that you see. The reason that's a little bit easier is because that's going to set up your axes for you. So in this case, this is a graph of life expectancy versus fertility rate. You can explore different variables in the upper left-hand pane. So we could look at CO2 emissions or cereal yield or energy use per capita. In this case, we'll look at GDP per capita. And you could probably use any of these three, whether we're using current dollars, $2,000, or adjusted for purchasing power parity. We'll get similar answers. We'll put this on the x-axis for now. And then we'll put life expectancy back on the y-axis. So rather than browsing through this list, if I know what I'm looking for, I can type it in the search box. But if you're doing this assignment, a good bet is you're going to want to be kind of browsing through this list and seeing what kind of variables are of interest to you. Now, everything that you create should have some kind of a pattern. Certain things won't. So if you find that you create a graph that doesn't have a pattern, you'll want to move on and select something else. GDP per capita or any kind of GDP-derived measure is going to be, you're only allowed to use 3 of those. So make sure you're exploring a variety of different variables. We can do the same things on the Google Public Data Explorer that we did in Gapminder. So we can highlight by region. We can sort of also get a visual sense of that, whether we mouse over or not. And another feature that we can do that we could also do on Gapminder is to change the axes. So both of these axes are what are called linearly scaled. So it goes up by even increments, 0 to 20,000, 20,000 to 40,000, 40 to 60, and so on. Life expectancy is jumping 20, 30, 40, 50, and so on. But if we go to the chart options, we can change those to log. And what that does is that scales the axis a little bit differently. They still go up in sort of regular amounts, but it's 1,000 to 10,000 to 100,000. So it goes up by a factor of 10 each time. And we could do the same thing with life expectancy, although we don't need to. Just by changing the GDP per capita to a log transform, we can see this straighten out. What that tends to do is it tends to reduce the amount of bunching that you get. So when you've got a large number of values that are bunching at one end, the log transform is usually a good bet to sort of stretch that out. So this should be a very similar plot. So here's Equatorial Guinea on this plot, same sort of data. So whether you're using the Google Public Data Explorer or Gapminder, you can interact with the data in the same way. This is a student example of an assignment that was turned in previously. So this is a plot of GDP per capita versus the refugee population by country. So we've got a nice scatter plot here, and then we have a nice paragraph, and we have a title. You're also going to want to cite your sources. So in this case, probably what we'll be using is Wikipedia, which is fine for this assignment. For future assignments, it won't be. So let's go back to Gapminder and talk about how we get this data back to our back into Word. I use a program called the Snipping Tool, which is under well, actually, it's easier if we just search for that. And earlier versions of Windows, it's under Accessories. So we'll search for the Snipping Tool. So it looks like this. It's got a little scissors. I use it so often, actually, that I put it on my toolbar down here. If you click on that, we can get a new plot. So I'm going to just try to get everything in here. That's going to include a legend, and it's telling me what my axes are. We've got some information here that's identifying it as coming from Google, and that's fine. So we'll copy, and then we can bring this into Word. We'll create a new document, and we can just paste that image in here. So you're welcome to use any screenshot system to do that. Just make sure that you're trimming out some of the extra information. I'm going to move this down a little bit. So delete that. I'm going to put my title here. We'll paste that back in here. And then this is where you're going to type your interpretation of the graph. So the titles don't need to be anything particularly fancy. A good thing that we can do is just name this according to the axes that we're using. So we could say something like income per person versus life expectancy. If you wanted to spice this up a little bit, you could use a headline, something similar to what Google uses. So if we go back, their headline for the initial graph was living longer with fewer children. This is describing the relationship between life expectancy and fertility rate. So if we wanted to say this, we could say something like more money equals longer life. Just a way to express the fact that we're looking at a positive correlation between those variables. So when you're writing your paragraph, all you really need to do is cite, is sort of describe the pattern that you see. So there is a positive relationship between income per person and life expectancy. Some regions are nearer the top of this trend than others. So for instance, sub-Saharan Africa is at the low end, while we'll say the Americas and Europe and Asia are nearer the top. So that sort of fits, and in fact, what we might want to say is there's a moderate positive relationship. So this is a fairly good line. We could imagine that being a little bit tighter, a little bit more linear. But it could also be quite a bit less strong of a pattern. So if we look at our sample from the previous student's assignment up here, this is a negative relationship, but much weaker. This cloud is significantly larger than the other one. So it's really just going to depend on your data, and you'll have to interpret that. I might bold the title as well to sort of make that a little bit stronger, and we probably want to put your name and the course in here as well. The last thing we might want to do is identify some outliers. So we could say one outlier is Equatorial Guinea, which has relatively high GDP per capita, but relatively low life expectancy. Now, going into this, we don't have any reason to know why that would be true. What we're doing is sort of using the graph to identify these patterns. So what we would want to do is look this up. So if we look up Equatorial Guinea on Wikipedia, we get some information about it. We've got a lot of sort of geographic information here. But even in this third paragraph, we sort of reach the explanation. So it says, since the mid-1990s, Equatorial Guinea has become one of sub-Saharan Africa's largest oil producers. With a population of almost 750,000, it's the richest country per capita in Africa, and its GDP per capita ranks 69th in the world. However, the wealth is distributed very unevenly, and few people have benefited from the oil riches. So the answer to this is that oil has been discovered off of the coast of Equatorial Guinea, and that's greatly added to the total amount of money that the country is earning per year. But that money doesn't really go out to everyone. It tends to stay in the hands of a few. So we just want to write that in here. So the reason for this is that Equatorial Guinea's GDP is rather high owing to oil production, but that the money from the oil doesn't reach the majority of the population, so life expectancy is unchanged. Okay, and there are a number of different ways that we could have written that up. The main thing is that we want to identify the general trend. We want to talk about regional differences, and we want to identify at least one outlier and provide a very simple explanation about that. And we would want to cite our source. In this case, we're going to use Wikipedia as our source. Again, for a more formal research paper, that would not be sufficient, but for this particular assignment, that's fine. So you're going to make 5 of these total graphs. I suggest you do 1 per page and then turn in a finished PDF when you're done. And if you have any questions, let me know. Thanks.